Okay, so let's go to question number 17. Can you read 17th question? 17th question. It's an exemplar question. A parallel plate capacitor is made of two dielectric blocks in series. We have done 3 questions of this kind on many occasions. One of the blocks has thickness D1 and dielectric constant K1, and the other has thickness D2, dielectric constant K2 as shown in the figure. The arrangement can be thought as a dielectric slab of thickness D is equal to D1 plus D2 and effective dielectric constant K. Then K is. Let's draw the figure. They have given it this way, K1 and K2. They have given the plates this way. Draw the figure. This is plate number 1, okay? Plate number 1. Plate number 1 here. Plate number 2 here, like this. The plates are held this way, okay? Right. Plates are held this way. Now what? It has two slabs, dielectrics. Look at that. Where is the dielectric kept? See this? It's kept somewhere in the middle, and then the distances are, this distance is given as D1, okay, and this distance is given as D2. All right. And this is given as K1, and this is given as K2. Filled with one dielectric, and this part is filled with another dielectric, okay? All right. Now, what is the first job to do? In such cases, whenever the plates are held this way, the first thing to do is to keep it in the vertical orientation, okay? Turn it through 90 degrees. So hold the plates like this, just turn it through 90 degrees. So the configuration looks like this now. We have a plate here. We have a plate here. Look at this capacitor plate number 1, okay? Capacitor plate number 2, right to the next of it, okay? Next to this plate. All right. And in the middle, we have a separation. Look at the separation. This distance is given as D1, the dielectric constant is K1. This separation is D2, the dielectric constant is K2. All right. The original figure is this, but whenever it is given top bottom like this, you just turn it through 90 degrees, keep it in the vertical orientation. Now I can wipe this part off. All right. So the figure looks like this. And I need to find the effective capacitance in this case. What is the equation for effective capacitance? The left half I'm going to take now. Left half is given by, capacitance of left half is given by, tell me what? The equation for capacitance is epsilon 0 K1 A by, the spacing is D1. Epsilon 0 K1A by D1. And I call it K1 into X by D1. What have I done? For calculation's easiness, I have called epsilon 0A as epsilon 0A. Look at this. Epsilon 0A was called Ex. That will make things easy for me. K1X by D1. Similar way, what will be capacitance of C2? Second part. It is epsilon 0 K2A by D2, which can be rewritten as K2X by D2. Now, we have learned this before. When they are left-right, they should be seen as a series combination. Top, bottom, top half, bottom half should be parallel, or top and bottom like this. If materials are filled this way, top side one material, bottom side another material, that must be taken as a parallel combination. But here it is left half, right half. They are coming in succession, so they must be taken in series combination. What is effective for series combination? C series is given by C1 C2 by C1 plus C2. What is C1? I can put it here. K1X by D1 into K2X by D2 divided by K1X by D1 plus K2X by D2. Okay. This is the total C effective or series combination effective. C series. All right, I'll simplify this one more time. Let me simplify this. See this. I'm going to write that CS one more time. What is CS now? CS is equal to, all right, what's on the numerator? This D1, D2. Look at that. This D1, D2. D1, D2 cuts after taking LCM. This D2 should come here. D1 should come here. No? LCM. D2 should come here. D1 should come here. Then I can cut D1, D2. D1, D2, D1, D2. They get cut. No? Both the denominators. Here the denominator is D1, D2. Here also the denominator is D1, D2. They are cut. What's on the numerator now? What's on the numerator now? K1, K2. K1, K2 into x square divided by. This is what? K1 D2x plus this is K2 D1x. Okay, I know that I have a common x on denominator. That is cut with this x, right? So finally, I have my equation CS is equal to K1 K2 by K1 D2 plus K2 D1 into x. What did I call x? Epsilon 0a. That is my equation number 1. Okay. But the CS, you're going to fill the entire space. Look at that. Look at that. Look at that. You're going to take the same capacitor. All right. You're going to take the same capacitor and fill the entire space with a single medium as per the question. With a single medium. That's what you're going to do, right? Single medium. What is the dielectric constant of it? It is called K, right? The dielectric constant is K. In the questions we did in class, I stopped here because all the questions were to find the effective capacitance. But now we have to go one step ahead. Now, instead of this, two separate media, you're going to replace what? You're going to replace the whole space with a single dielectric. So what do you write for it? Epsilon 0 Ka by epsilon 0 Ka by total spacing is, they have called it D. What is that D there? D is D1 plus D2. D1 plus D2 should be equal to what? This is K1 K2 by K1 D2 plus K2 D1, K2 D1 into epsilon 0A. One last step, epsilon 0 cuts on both sides, A cuts on both sides. This goes to the right-hand side. I have the final answer. K is equal to K1 K2 into, this is going to the right, D1 plus D2 divided by K1 D2 plus K2 D1. This will be the final answer. Okay. This will be the final answer. But trust me, this won't come as an MCQ. It will come in a subjective question, maybe 2 marks. All of you understood this?